everyone, welcome to the session over Synapse Link. My name is Shireen Bahadur and I'm a PM in the data integration space, specifically supporting the Synapse Link product. As for the agenda and what we plan on covering during the session, we'll first start up with an introduction to Synapse Link and then dive deeper into Synapse Link offerings, which include Dataverse, Cosmos DB, and now SQL. And then we'll wrap up at the end. So Azure Synapse Link is a cloud-native implementation of HTAP, hybrid transactional analytical processing workloads. In the past, supporting HTAP workloads has been really complex and costly, thus forcing customers to make trade-offs between transactional and analytical needs. Most customers have had to provision resources to support analytics and transactions in a single system, or they've had to maintain multiple different systems. While managing multiple systems, customers have to manage complex ETL operations to connect their analytical systems, and sometimes this results in a delay to reaching their near real-time insights. With Azure Synapse Link, customers are now able to get insights from the operational databases in a single click. And on top of that, customers don't need to worry about managing data movement, and there is minimal impact on their existing operational stores. You no longer need to build complex ETL pipelines or allocate additional database compute resources. And now customers are able to run their analytical workloads on real-time data directly through Azure Synapse Analytics. Azure Synapse Link is now available in Dynamics 365, Cosmos DB, and now the Azure SQL DB family, which includes Azure SQL Database and SQL Server 2022. Now moving into the value prop of Synapse Link. At the end of the day, why is Synapse Link so helpful for customers, and what is the value that we're providing to our customers? First, it's simple. Enabling Synapse Link is a one-click experience, and you can create it without creating any additional pipelines. Second, you're able to view your operational data in Synapse Link quickly, Azure Synapse quickly, and perform near real-time analytics. Third, fundamental to our Azure Synapse Link is our cloud-native architecture, and this is a fully managed service, so customers do not need to have to worry about maintaining the link. Fourth, with the existing Spark power in Synapse, customers are able to leverage the existing strong analytical performance and provide BI, visualizations, and dashboarding out of the box. And lastly, there is little impact to the transactional performance when using the link. Now I am going to hand it off to Jason to speak more about Synapse Link for Dataverse.
Thank you, Shireen. This is Jason, PM for Synapse Link for Dataverse. Before introducing the Synapse Link for Dataverse, I would love to give some context about what is Dataverse and why we need to use Synapse Link. Dataverse lets you securely store and manage data that's used or generated by business applications like Power Apps, Power Page, Power Automate, or Customer Insights. Compared with other data services, Dataverse is a fully managed low-code cloud data platform to structure data, events, logic, and insights for daily operations in a really secure and efficient way. And we all know data is a new oil, but Dataverse does not really offer computing resource for you to consume the data to get further insight. It says that manually exporting these table data will possibly lose lots of valuable meta information. So we introduced Synapse Link for Dataverse to take both data itself and metadata from the Dataverse to Synapse Analytics in near real time. And it is not just a one-time data expert service, but a pipeline to connect your Dataverse environment to the Synapse workspace with incremental updates to generate near real-time insight. We saw users consume the data in different ways. For example, to Synapse workspace, like a data warehouse, to run some analytics using machine learning, to do some data visualization or export data further to other destinations like Power BI or Azure SQL. And next slide, please. And in this slide, we want to introduce a vision called One Synapse. Instead of asking the user to find the tool, identify the data, allocate the computing resource, and identify the connector for output, we provide an end-to-end way to work with the data. When a user enables the Synapse Link in Dataverse portal, they can turn on Synapse Workspace with one click to get everything ready to consume. And after building a link from Dataverse to Synapse, all the selected will be synchronized automatically, and users just need to click a shortcut. It directs them to Synapse. and the user can find building data views with metadata embedded and computing pool like serverless pool or Spark pool to ready to render data. Next slide, please. And to realize the one Synapse vision and keep the low-code or no-code environment promise in Dataverse, we want to make it easy for users to use Synapse links in both Dataverse and Synapse Workspace. So we keep delivering new features to improve user experience. And the first one is about consuming metadata directly in Synapse. As we just introduced, Dataverse contains rich metadata information, and we want to make sure these metadata can be easily consumed without writing some complex code to extract from backend file. For example, option set or choice is a type of column that can be included in a table. It defines a set of options, and the user can use a drop-down menu to select some choice. But by using this new feature, the user can easily replace numbers with meaningful text value without writing a single line of code. And for the second one, we know the data in Dataverse keeps operation data. So instead of providing one single file, we provide incremental folder to help user query and analyze the incremental updates during a user customized time frame. That can be really helpful for organizations with large data sets to drop historical data to save data processing costs or increase efficiency in Azure Synapse Analytics to only track data changes in their preferred time interval. And for the third one, we used to push the data into a CSV format with a JSON file containing the metadata. It works fine, and we have lots of customers using it, but we know it is not the optimal solution. So in the mid-August, we will support Parquet plus Delta Lake for efficient storage, better performance with guaranteed ACID transactions and time travel feature. And next slide, please. So for ready-to-run experience, after you push the data from Dataverse to Synapse, you can use 3 ways to consume the data. We just want to make sure everyone, no matter if you are a professional in machine learning or have zero tech knowledge, all customers can benefit by consuming the data in Synapse Workspace. Serverless SQL is an easy way to help you view the data, better understand the data, or join different tables to get data ready for future use, like export to Power BI report. And for pipeline or data flow, you can use it to get external data into the Synapse Workspace and combine it with your own data to get more meaningful insights without writing a single line of code. And the third one is Synapse Spark, which might be the killer function here. It requires some technology expertise, but it is a perfect place for customers to start applying big data analytics on your near real-time data. And next slide. Before jumping to the demo, I want to give you a quick intro about what we are going to present. This is a use case inspired by a real scenario. Let's say Contoso is a medical center and is targeting to make sure they have enough PPE in their storage. A local government might send some real-time requirements of the PPE storage weekly or daily based on the focus of patient flow. It is going to be really time-consuming to track all the equipment manually. So they use Synapse Link to push the data and pull the requirement from government using pipelines and making a comparison with their current inventory storage to come up with a Power BI report. Then the supply department can check the report and manage the stuff properly. Okay, Shireen, I think we can now play the demo video.
First, navigate to the Power Apps Maker portal. In the Power Apps Maker portal, Azure Synapse Link is under the Dataverse tab. You start creating a new link. Already created your Azure Synapse Analytics workspace as well as your storage account. We will select Connect to your Azure Synapse Analytics workspace, specify an Azure subscription, a resource group, a workspace name, and a storage account. Then hit Next. Then we will select the tables we want to prepare for export. In this case, it'll be the account table and the personal protective equipment table. Once you're redirected back to the main page, select the link from the list. Ensure that all the tables have an active sync status. Then select Go to Azure Synapse Analytics Workspace. Once you've successfully redirected, expand the Lake database from the left-hand side and then expand your Dataverse database. Then expand tables to see the Dataverse tables you've prepared for export, in our case, account and personal protective equipment. To query the tables, select the three dots and then select New SQL Script and select Top 100 Rows. This utilizes the built-in serverless SQL pool to query your data. Not only can you query the data, you can also create a quick visualization within Synapse by selecting the chart option. You have a multitude of chart types and different ways that you can categorize the data. Now we will go to step 2 and create a Spark notebook. To create a Spark notebook, go back to your table, select Actions, New Notebook, and Load to Data Frame. This will create a default Spark notebook that selects the top 10 rows out of the table. To run the notebook, make sure to attach to a Spark pool and then hit Run. For the purposes of this demo, we've pre-built a Spark notebook that contains the code to join the account table and the personal protective equipment table. Here is a pre-built Spark notebook that joins the two Dataverse datasets. First, let's take a look at the data. We use SQL to query the PPE table, which shows me the item, inventory, unit, and the account ID that provided this item to Contoso Medical Center. In the account table, we see an account ID and an account name. Now we use Python to join the datasets based on the account ID field to get a human-readable version of the data that is written to a new Spark table known as PPE account. We go back to using SQL to query this joined dataset, and we can also find the dataset under the default database under Tables. Now let's look at step 3, which utilizes a Synapse pipeline to derive a column that identifies the PPE that is running low. So first I will create a pipeline, and within this pipeline, I use a mapping data flow. First, I bring in an external dataset that tells me how much of each PPE our Contoso Medical Center should have. We then join that data with the joined Dataverse data from the previous step. I then use a derived column calculation to create a new column that identifies the PPE running low, and if so, how much. Once I format the data, I sync the data back into the default Spark database. And this is a view of what happens when my pipeline is completed. I see the item, whether or not it's running low, and if so, by how much, and the account name that provided me this item. I can also see this new table that I've created by going to the default database and refreshing. Under Tables, I now see that I have my PPE running low table. Now we will create a Power BI report. Once you've launched Power BI Desktop, select Get Data and More. Select Azure and Azure Synapse Analytics SQL DW connector and hit Connect. For the server, paste your serverless SQL endpoint that it can be found on the Details tab of your Synapse workspace in Azure. Make sure to select Direct Query and hit OK. Now on the Navigator page, I have the option to select any of the tables from any of the databases in my Synapse workspace. In this case, I can select my Dataverse tables, account or personal protective equipment, as well as some of the Spark tables we created, PPE account and PPE running low. In this case, I'll select all of them. And then I'll hit Load. And that is how you can create a Power BI report over your Dataverse data using Azure Synapse Link for Dataverse.
All right, looks like it's time for Azure Synapse Link for SQL. My name is Chuck Heinzelman. I'm a Principal PM Manager with the Azure Data Team, leading up our Data Platform Analytics pillar. And I am really excited about the newest player in the Synapse Link family, Azure Synapse Link for SQL. So as with the other Synapse Link flavors, we really want to enable you to be able to do analytics on your data as fast as possible with minimal impact on the source systems in a way that's going to really work for analytical workloads. And that's one of the things we are really striving to set out or striving to get to here with Synapse Link for SQL. We are using a new technology in SQL Server called change feed, which is putting minimal load on the source systems in order to get the data out and into the analytical systems. You don't have to do any custom ETL. Part of the big problem with doing this type of workload traditionally was you had to write ETL packages. You had to run them on a periodic basis. You had to maintain them. You had to put extra load on your server, whether you were querying from change data capture tables or querying directly against the source tables with some sort of date filter. You were adding additional overhead to your system. With this, we are able to move data from your source databases into Azure Synapse Analytics dedicated SQL pools without you having to write a line of ETL code. And we do this in near real time. We are constantly looking at the transactions that are coming through on your database, and when a transaction for a table comes through that you are monitoring, you are replicating, we grab that and we move it over into Synapse automatically for you. Next slide, please. All right, I want to talk a little bit about a couple of the core concepts here. On the source side, we support Azure SQL Database and SQL Server 2022. Now, I have to put a caveat on this with SQL Database. We do not support managed instance right now. It is the PaaS offering of Azure SQL Database. And our destination is the dedicated SQL pool in Azure Synapse, what you might know as, formerly known as the SQL Data Warehouse. Some of the moving parts here that we have this thing called a link connection. Now, a link connection is what maps your source database through to the destination. We can have multiple tables in a link connection. You can specify the target schema and table name. You can specify the way you want to store the data in the dedicated SQL pool. You will see that in the demo later. But the link connection is really the glue that binds this all together. We also have a landing zone. Now, for anyone that's done IoT projects, your devices don't write the data directly into your backend systems. They use some sort of buffered ingestion point like Event Hubs or Kafka. We are doing something similar here. We have a landing zone, which is an ADLS Gen 2 account where your source database systems write the data into it, and then it can be picked up by an ingestion service and moved into the dedicated SQL pool on the back end. For Azure SQL Database, we manage this landing zone for you. For SQL Server 2022, it is a customer managed landing zone. It's a standard ADLS Gen 2 account that you create and set up the permissions on. One other piece here, and this is a SQL Server 2022 only piece. We use the self-hosted integration runtime component that anyone who's used Azure Data Factory or Synapse pipelines, you're probably familiar with the self-hosted integration runtime. It's a software agent that you install on premises. We use it to broker command and control between Synapse and the on-premises SQL server. In our case, the database engine is still the one that is writing the data into the landing zone. The integration runtime is there to broker the commands between the two. Next slide, please. So we talked a little bit about the architecture, but this is kind of the flow of it here, where we have your source databases on the left-hand side, either SQLDB or SQL Server 2022. The change feed is pushed into the landing zone. The two landing zones here, they're both ADLS Gen 2. The difference between them, again, is that with SQL Server, we manage it. Or sorry, with SQL Server, you manage it. With SQL Database, we manage it. One thing I have to say about this is an intermediate temporary storage. It is not something that you should be using if you are using Synapse Link for SQL. You should not count on any of the data in this landing zone. It's transient. We can change the format at any time. We can change the storage duration at any time. Do not use this for anything other than its intended purpose as that buffered landing zone between your source systems and the backend systems. We then have an ingestion service that's running. I mentioned this a little bit. It's taking the data out of that landing zone and putting it into your dedicated SQL pool. Now, when we first brought this out in preview, the only way to do that was in continuous mode, where that landing zone or that ingestion service was running 24/7. We have, since it is in preview, we have introduced what's called a batch mode, where you can tell that ingestion service to pause itself, go to sleep for a little while, if you don't need the near real-time nature. So if you want the near real-time, you leave the ingestion service running in continuous mode. But if you can accept the latency, you can put it into batch mode to save a little bit of money. All right, next slide, please. A couple other things before we get into the demo. I want to stress this is a fully managed thing. The service, you manage it through the Synapse workspace. You'll see that in the demo. You can tune your performance. We have enterprise-grade features that some of them are there, some of them are coming out still in our preview timeframe. We are in public preview as of right now, which is August 1st when I'm recording this. But we have things that are coming that are making sure that this is an enterprise-grade feature. The tables are one-to-one map. The source table maps to a table in the destination database. You will see how we can do consolidation in the demo, but we do have a one-to-one mapping of the tables. We do allow you to maintain transactional consistency for these tables. You can turn that off, but we do support transactional consistency. This is on the back end. We do not change anything with the front end. Your source systems are always going to be their transactional consistency. We don't tweak that. This is all on the writes on the back end. Interoperability. The data is landing in a Synapse dedicated SQL pool. Anything you can do with that dedicated SQL pool, once the data is there, you can use that. So if you want to hook it up to a visualization system, if you want to do some ETL processing after we get the data out, you can do that. You can connect to it using the Spark SQL connector from either Synapse Analytics Spark Pools, Databricks, or your own Spark environment. It is, at that point, a Synapse dedicated SQL pool that just has your data in it automatically replicated for you. And again, we support PaaS, SQL DB, we support IaaS, SQL Server running in a VM, or SQL Server running in your on-prem environment. All right, next slide, please. And with that, I think we can take you into the demo. What I'd like to do now is give you a demo of Azure Synapse Link for SQL actually running in an environment. So what I have here is I have two databases. These are both based on the Wide World Importer sample database that we publish. One of them is running an Azure SQL database. One of them is running in a SQL Server on premises. It's a SQL Server 2022, instance running on premises. These databases, they have the exact same schema, but they've been separated by what data is in them. In the cloud version, if I run this, you can see that I have 261 rows, and these are actual end customer records. In the on-prem version, if I run this, I have 402 rows, and these are distributors. So we are running the distributors out of our on-prem system. We are running the actual end customers out of our cloud system. So how do we get this data into Azure Synapse Analytics? Well, I have set up here two link connections already up and running because it takes a little while to get them configured and up and running. I didn't want to take the demo time for that. But each of these link connections, I have one for on-prem, one for my cloud source. Each of them, I have a list of tables from those sources. I have the source table, and I can specify the target schema and table name that I want to use. And in this case, since I have the identical schemas in two different places, I'm bringing them into a single dedicated SQL pool. So I'm giving them different schema names on the way in, and then I'm using views to union those two sources together to get my output, which you'll see a little bit later. One of the things you can do on these tables is define how you want Azure Synapse Analytics to store this data. Do you want it to be round robin? Do you want it to be hash distributed? Do you want it to be replicated across that dedicated SQL pool? You can also choose, do you want it to be a clustered column store index or a heap for optimizing your workloads depending on what table types you have. So I already have these two up and running. And if we go into this customers query, this is querying the view that I have that unions those tables together. And just to prove that the data that was cached on the screen is not just smoke and mirrors, this is the actual counts that are in that database right now. We have 261 cloud customers and 402 records in the on-premises database. So let's go and add some data into those systems. So I'm going to go into my on-prem or my cloud database. Actually, I'll start with my on-prem database. I'm going to add 50 records on-prem. And then I'm going to add 100 records in Azure. And if I rerun this, this customer's query, you can see I now have 361 records in the cloud. And I have 452 records on-prem. So what's happening now is the source database systems are pushing their data, these changes, into that landing zone that we talked about. And from the landing zone, the ingestion service will pick it up and it will move it into the dedicated SQL pool. So all of that is happening behind the scenes for you. You didn't have to write any code to do it. All you had to do was set up that link connection that I showed you in Azure Synapse. So if I go back into my Synapse environment and rerun this query, there we are. In just the time that it took me to explain what's happening behind the scenes, those 150 new records were moved from those two separate sources into one dedicated SQL pool. And what can I do with it from here? Well, I can do anything I can do with a dedicated SQL pool. I can connect client tools to it and run queries. I could connect to it with a Spark pool through the SQL connector. What I want to show you, though, is I have a Power BI report running in direct query mode. This is the old data from before we inserted those records. If I refresh this Power BI report, you're going to see, since we are running in direct query mode, we now have 813 total records, 361 from the cloud and 452 from on-prem. So I just wanted to show you how straightforward it is to get this set up and running and actually have data replicating in near real time from multiple source systems into a single dedicated SQL pool.
Okay, thank you, Chuck. Hello, everyone. My name is Rodrigo Souza, and I'm a Senior Program Manager with the Cosmos DB team. Now, we're going to talk about Synapse Link for Azure Cosmos DB. So, the next slide, So, how customers could do analytics on Cosmos DB before Synapse Link? On the left, we can see that an example of how customers were running OLTP and OLAP workloads on the same database. This minimalistic implementation brings a couple of challenges. The first one, you're going to have a performance impact on both workloads because they're going to compete for the same Cosmos DB resources, right? Also, you can, this implementation blocks customers to archive their data. So customers need to keep their data for longer in the Cosmos DB transactional store. And this brings costs and performance issues as well. And lately, the cost and latency increased due to the volume data volume grew, right? On the right, we have another type of implementation for analytics on Cosmos DB, again, before Synapse Link. We saw customers exporting the data to a data lake or something like that. And this architecture also brings challenges. Let's see what are the problems here. So the first one, you have to create ETL jobs to periodically export data into a data lake and then into a analytical database, and this brings costs and maintenance. It's the regular challenge of ETL jobs. Also, it brings delays on your capability to get insights from your data, because you can run these jobs around the clock. And if you're running every night, you already have a delay on your capability to extract insights from your data. And not to mention, you need to manage the whole environment, not only the ETL jobs, but data format, storage, and so on. So this was a scenario before Synapse Link. And let's see how we try to address these customer challenges in the next slide. So with Azure Synapse Link for Cosmos DB, we try to simplify the analytics architecture. On the left, we can see a regular application loading data into Cosmos DB transactional store. That's the Cosmos DB regular containers, you know. And behind the scenes, for the containers that customers enabled Synapse Link, we're going to sync the data into a storage account, a managed storage account. You don't need to worry about it, in a columnar format. We call this data analytical store. Right? An analytical store, it's a columnar format that is optimized for analytics. And this analytical store can be read, can be accessed, can be queried through what we call Azure Synapse Link. That's the link, that's the cloud native link between Azure Synapse runtimes and analytical store and Cosmos DB. Which runtimes? Synapse Spark and Synapse SQL Serverless. These runtimes, they unlock workloads like machine learning, big data analytics, and BI dashboards. A couple of important details here. The first one, this sync between transactional store and analytical store won't use Cosmos DB customers RUs. That's a request unit. That's the throughput unit customers buy from Cosmos DB, right? So, and this is the most expensive resource you have on Cosmos DB. So, for this sync, we are not using customers RUs. Second important point here, analytical store is not only optimized for analytics, it has up to 90% compression. So the data footprint will be up to 90% smaller. And analytical store pricing is 10% of transactional store prices. So that's 90% savings on 9% data reduction, right? Compression. And the third point here is that when you're using Azure Synapse runtimes to read from analytical store, you're not using RUs. You are just using regular Azure Synapse analytics pricing, right? And Synapse Spark, they charge per vCore hour, and Synapse SQL Serverless will charge customers per terabyte scan. Right? So, but again, customers are not using RUs. And the last detail about this slide is that phrase, I'll generate near real-time insights on your operational data. How is this near real-time? How much near real-time it is? We are making data available for analytics in up to 2 minutes. And doesn't matter how much data is being loaded, updated, or deleted, right? We are keeping this 2 minutes performance. Another one last comment is that Synapse Link for Cosmos DB is GA since last year, right? So In the next slide, let's see yes. Let's see what are, in resume, what are the key benefits for Azure Synapse Link for Cosmos DB. So customers will automatically sync transactional data to an analytical store. And again, no performance impact on your transactional workloads. Actually, you can optimize your data model, your request units, your storage for your transactional workloads. Why? Because analytics will happen somewhere else, right? In an analytical store and with Synapse. Again, the near real-time replication is up to 2 minutes. Cost reductions. No Cosmos DB RUs are used, again. The consumption-based pricing for an analytical store inquiries. So to scan a terabyte of data typically will cost 0.065 cents. To move the expensive cross-partition queries to Azure Synapse Analytics. So these are the most expensive queries you can run in Cosmos DB, cross-partition queries. Let's say you have an IoT scenario, you have thousands of devices, and device ID is your partition key, and you want to see all data from yesterday, from all devices. This is a typical, very expensive queries, and this type of queries now you can run over analytical source through Synapse Link using Azure Synapse Runtimes. Data tiering, that's very important. Cosmos DB transactional store has what we call transactional TTL, time to live. So for how long data is kept in transactional store. Now we have independent TTL for analytical store. So we are seeing customers using analytical TTL bigger than transactional TTL. With that, you can keep your most recent, your hot data in transactional store and use analytical store to keep all of your data for analytical purpose. Again, the compression and the cost, 90% compression, 10% of the cost. You don't need to manage storage, ATL, data format. We have the automatic schema inference. So any new data format, any new property you add to your data model, it will be automatically represented in analytical store. And we have in the portal these two one-click integrations with Azure Synapse Analytics. We have this native integration with Spark to unblock data science or data engineering workloads on Cosmos DB data. And also we have this integration with Synapse to allow customers to, with a couple of clicks, to create Power BI dashboards using Synapse SQL Serverless. And with that, customers can start to do joins between their Cosmos DB collections, what was not possible until now. They can run SQL, T-SQL start procedures, aggregations, and so on. So a very powerful capability for your Cosmos DB data. And another detail, since Synapse SQL Serverless is a regular T-SQL engine, you can use the BI tool you prefer. One last detail here I would like to talk about is that in Cosmos DB, you need to, until Synapse Link, you should choose a partition key that will bring balance between queries and data ingestion, right? And it's very hard, it's very complicated to find a partition key that would bring good performance and cost for both kinds of workloads. Now, customers can module their data. They can choose a partition key. We focus on data ingestion. Again, OLAP, analytical workloads, will happen somewhere else, and the partition key isn't important anymore for analytical workloads. Let's go to the next slide, please. Yeah, so here we are seeing a couple of examples, real examples from customers using Synapse Link. This one is a real-time recommendation we have a customer using. And before, on the left, they used to have delays of insights because they were running ATL jobs at night, and it was really expensive. The ATL jobs start to run over the morning. A lot of regular challenges we are seeing customers with big data volume, right? Not to mention the overhead to maintain the infrastructure for these ETL jobs. Now with Synapse Link, they have a way more efficient architecture, and the e-commerce data is available for analytics in seconds, right? And now they are unlocking new scenarios like to provide real-time recommendations for their customers, and they also could reduce the performance impact of the ETL jobs in their OLTP transactions, right? And again, they don't need to manage storage for ETL jobs anymore. Let's see the next slide. So how much money we can save with Cosmos DB? On the upper right corner, we have, we did a test, right? And this is our TCO comparison. And on the upper right corner, we can see the environment we use for this study. So Cosmos DB max autoscale RUs, 1 million RUs. Ingestion, 10 hours of data ingestion, and the total storage close to 2 terabytes. So on the left, we can see the costs and the reads with using Azure Synapse Link. And at the end of the day, the total cost for data ingestion and to process the data and generate golden records of the workload, total cost would be close to $1,339. On the right, to do exactly the same thing without Synapse Link, but using Spark, customers would have to spend something like $3,583 to do exactly the same pre-processing and generate golden records for this hypothetical retail scenario. So that's, in summary, that's 63% cost reduction with Synapse Link to do exactly the same thing. Next slide. So what's available now? It's GA since March 2021. API supported SQL API and MongoDB API. Runtime, Synapse Spark and Synapse SQL serverless. Now we support existing containers. In the beginning, we will only support new containers. We have this new Power BI integration in the Azure portal. We have enterprise-ready security capabilities like VNet and customer managed keys. And we have this custom partitioning support for analytical store. This is important for really big data volume scenarios when customers need to repartition analytical store. And what's coming next? We are working on support point-in-time restore. Gremlin API, we also have Synapse Link. As you know, Cosmos DB has a Gremlin API. And we are working on support for existing MongoDB containers. I also want to mention that you can contact the Cosmos DB Synapse Link team with this email address you can see at the bottom of the slide. And also I want to call out the Synapse Link for Cosmos DB deep dive session we have here in this exactly same conference. I think it's over. Let's see the next slide. Oh, yes. Let's see how it works. How is this Power BI integration in the Azure portal? So on the left, you can see we have this left navigation menu, and Power BI is selected. And in that tab, in that plate, you can enable Synapse Link for your containers, and then you're going to navigate to Synapse workspace. You're going to create the database. You're going to create the SQL serverless pool if necessary. And at the end of the experience, you download a Power BI file with a connection, with integration to your Cosmos DB enabled containers, right? To your Synapse Link enabled containers in Cosmos DB. So this is the Power BI experience we deployed a couple of months ago, and we have thousands of customers using this pretty simple way to create Power BI dashboards. Let's see if I have another slide. Oh, yes. To learn more, oh, I think it is back to you now, Shireen. This slide is ours, not
No, you're
mine.
good. Thank you, Rodrigo. But yeah, we did present a lot of information in our Synapse Link offerings. And if you want to learn more, we have provided an index with some documentation links to some of the features that we've mentioned in the presentation today. Cool. I guess this brings us to the end of the session. Thank you all so much for your time, and thank you to our speakers, Jason, Chuck, and Rodrigo. We will still be available through chat, so please feel free to post any questions there. Thank you.